All right, so we're looking at this function. We see the a, h, and k just like normal, and those are all going to have the exact same effect that they typically have on the graph. The a is the stretch factor. H, k, we switch key. And so, when we look at this, we can see that the HK, it says here, is the intersection of two asymptotes. Asymptotes is a new vocabulary word. The vertical asymptote, x equals h. The horizontal asymptote, y equals k. Those come from HK. So, what is an asymptote? It's a boundary line that the function does not touch or cross. So that means there's going to be an imaginary boundary line. It's going to be like a wall that's going to prevent the function from going through. For this function, the parent is 1 over x. And so when we're plugging into the parent t table, plugging in -2, -1, and then we're going to plug in -0.5, 0, 0.5, 1, and 2. When we plug these in, we're dividing them by x. And so to do that, we're going to get our y values. I'm going to start in the back over here. So I'm doing 1 divided by -2. This is the idea in our brain. And what is our answer to this as a decimal? We'll start with Sydney. 1 divided by -2. 0.5, and because of the negative, -0.5. Next, we're going to get the -1. So we're thinking of that as 1 divided by -1. And Anthony, what do we get for this one? Then we're moving forward. We're doing 1 divided by -0.5. This is a little bit confusing. So I'm going to show our work for this one. This means 1 divided by, and then I'm going to write the -0.5 as the fraction -1 over 2. And when we see it horizontal like this, hopefully this reminds you of the next step. When I see this, in order to move forward, I need to multiply. And so this actually changes to 1 times, and maybe you remember the name of the fraction that we multiply this by. It's called the reciprocal. Have you guys heard that word before? So we're going to multiply by -2 over 1. And what's the result for this altogether, Yvonne? 1 times -2 over 1. -2 over 1, which we're just going to write as -2. And so we're beginning to see what's called the reciprocal relationship here. It's not very clear with the 1, but with the -2, we get -0.5 as the output. But when the input is -0.5, the output is -2. It's a flippy-dippy relationship. The input becomes the output becomes the input. And it switches. It's called the reciprocal function. And so if you see the word rational function or reciprocal function, those are going to be synonyms, just the same way that zeros, x-intercepts, roots are all synonyms. The next one that we come to is 0. And when I write that, that's 1 divided by 0. And hopefully you guys know the answer to this. It's a very interesting answer. And are we allowed to divide by 0? No. Is anyone allowed to divide by 0? No. It's a mathematical conundrum. It's the mystery of mysteries. And so what is the answer to this? 0? 1? It's undefined. Thank you, Lauren. This is undefined. And so I'm going to write that as the empty set on here, just as a placeholder, because these double empty sets are going to be the HK, the intersection of the asymptotes, because dividing by 0 is what creates the asymptote. It creates this very strange situation. But then we get to the 0.5. same thing as this one, but without the negative. Gavin, what would we get when we plug in 0.5 as our output? 2. And then following through, when we plug in 1, this one's pretty clear. Lauren, what would we get? 1. And then for the last one, we get the 0.5, and I'll just fill that in for us. So for this, we're having a vertical asymptote at, for the parent, 1 over x. The parent is at x equals 0, and y equals 0, right? That's just the parent has the hk at 0, 0. And on the parent, just like always, the a is equal to 1. So when we go to graph this, I'm going to use my highlighter to indicate the asymptotes. So the first thing that we're going to do is we're going to plot the hk at the origin. And instead of this being a coordinate on the ordered pairs, this is where we'll draw the vertical. And I draw it as a dashed line and the horizontal asymptotes. And hopefully you guys can see these as dashed lines pretty clearly. They're overlapping the axes. Now we're going to plot the coordinates that we expected. This is x, this is y. So I'm going to -2 for x, and I'm going down 0.5. Then I'm going to -1, -1, and then I'm going only half a unit to the left and down 2. So we have 3 ordered pairs, and they're making this really beautiful curve. I had asked my first period if anyone had an opportunity. I got to do this in maybe 5th grade. We took a block of wood, and we put these axes on it, and then we tied little tiny, were they tacks maybe? And then we did string. And we made this cool string art, and I started up here, and I went down, down, and then I connected the next one. And even though it was just straight lines, it began to make this really cool curved shape. I wonder if you guys got to do something like this when you were in elementary school or not. Okay, and look, I did the other side, and so it creates this kind of cool curved shape. And so it's almost similar to this. So you're seeing, oh, it's kind of creating this cool curve. So let's go a little bit further. I'm going to tell you the domain and the range so that we can finish the end, because we haven't filled in these other values, the extreme points. So looking back at our parent table, could I plug in any x value in the denominator that's extremely negative? Could I plug in negative infinity here? Can you divide by -100 billion million? Yeah, 1 divided by that was just going to be a teeny tiny decimal, because what's 1 divided by 100? 0.01, 100. 1 divided by 1,000 is 1,000. 1 divided by 10,000 is 1/10,000. And do you guys remember that as decimals? Here's 1 divided by 1, 2, 3. 1, 1, 2. Third decimal place is the 1. Sorry, I was out of spring. Then if I had it as 1, 2, 3, 4, that's 1. And then we go over 1, 2, 3, 4 from scientific notation. So all that to say, our domain includes negative infinity. Then we're going to go all the way to h. The number here, but we will not include h. So we're coming from the negative side up to h, soft bracket. This is going to remind us of unit 1. Then we have our union. Then we're going to start on the other side of h, because I can plug in numbers that are very close to 0, such as 1 divided by 1 over 10,000. And what that creates is actually, isn't that crazy? 10,000. Because I would multiply by the reciprocal. There's a basket on the desk. And so this is going to go from h to positive infinity. other side, we're at 0.5, and then we go up 2, 1, 1, and then we're over 2 and a half. We'll do the exact same thing. So we'll start way up here, come down, and then we want to go through. We can't cross through, so we just kind of flatten out. And I call this like a beautiful star shape, very fitting for this season, right? We're in the season of the different stars. So we're seeing that the x goes from negative infinity, goes stops here, and then we start over here, and we go to positive infinity. The y values start at negative infinity, they stop, and then they start again and go up to positive infinity. So if this is how we wrote our domain using h, please write in the range, but use k instead.
That's just like a formula, right? So if you already have it.
Yes, because these are your notes. This is what you should have written for the range. This is what you wrote. You replaced the h with k. Hope so. This is what our parent function looks like. It's centered at the origin. The a is 1, so we go over 1 and up 1, and down 1 and over 1. Now let's look at a function that's been transformed. So we see the a, the h, and the k. Take a quick moment. Fill in the a and the h, k, switch key. Following the standard rules like we normally use. And then where was I left off at? Lauren. Catherine's testing. So hopping back to Ryder. Ryder, what do we have as our a value?
-3.
Good. And our hk, what would it be, Chris?
-2, -6.
Very nice. So we're going to make our transformation table. We have plenty of space here for that. And I'm going to make a nice column here. I'm going to do my dark pink, like the parent. And then I'll have -2, -1, -0.5, empty set, 0.5, 1, and 2. Then I'm just going to copy the values from before, giving me my -0.5, -1, -2, empty set, 2, 1, and 0.5. Then I'm going to put my labels at the top for the x plus h and ay plus k. But I want you to include the correct numbers that we're expecting here. So for our x plus h, Naomi, what would we have for our x plus h this time? That's right, x minus 2 here. Drawing this down so I don't get confused. And then Leo, what would our ay plus k be?
-3y -6.
Very nice. And so now we're going to run the computations. We're taking -2, subtract 2. There are some decimals, so be careful. So -2 minus 2, they're both negative. We add and keep the sign the same. Allison, you're up. -4. And then we have the next one.
-3.
-3. Next one.
-2.
Good. Here we're going to just put our h value, -2. And now we're having -2 plus 0.5 because they're opposites. So what do we get here?
-1.5.
Very good. And then we have negative. Grayson, you ready?
Yeah, I just said it, but -3 or -1.
And our final answer.
0.
So we're feeling pretty good about these. So all this to say, over time, right, we won't necessarily need the parent function. We start with the parent function to understand the shape. And after we get more familiar with it, we start to understand the relationship with the a, the h, and the k. Grayson.
So how did you get like the x's to the y's, like the parent functions? Okay.
So in the parent function, you always pretend that a is 1 and getting positive 1.5 minus 6. So Jared, where are we at with positive 1.5 minus 6? 4.5. You guys can see the decimals a little bit tricky. We've got to go a little bit slower there. Then we're doing negative times a negative. We're getting positive 3 minus 6. And what are we getting for that one, Jared? Positive 3 minus 6. Negative 3. Then we're doing negative times a negative. We're getting positive 6 minus 6, last one. Then we just put our k value. This is meant to be our h. This is meant to be our k. Then we're going to come to the other side. That's going to be 2 in the y. We're getting negative 6 minus 6. So Elijah, where are we at for this next value?
For 2,
Yes.
negative 12,
Very nice. And then for 1.
negative 9,
And finally, we're getting negative 1.5 minus 6.
negative 7.5.
Nice. So what are we going to do with all this? It's kind of confusing. There's a lot of coordinates. We don't want to get confused. We want to have a strategy. So step 1, plot HK. Let's start by plotting the HK. Negative 2, negative 6. What are we going to do through there? And sketch. Oops, that's a CH. I want you to sketch a vertical line and a horizontal line passing through HK. So that's going to go all the way up and all the way across. To make it more clear, I'm going to use my highlighter just so that you can see it. These are my asymptotes. Okay, 2, plot, coordinates. So because these coordinates are stuck, they're going to be in one quadrant at a time. So these ones here will all be on the same side in one of the quadrants created by the asymptotes. These ones here will be in another side. So if you notice them crossing, stop, you've made a mistake. Because remember, they can't cross. It's going to be this shape stuck inside of one. It could be in here, it could be in here, it could be in here, or it could be in here. So here I am, I'm at negative 4 for x, and then I'm going to go down to 4.5. There's 4.5. Then I'm at negative 3, negative 3. Okay, that one's easy. Then I'm at negative 2.5 and 0. So I can see that if this was quadrant 1, 2, 3, 4, I'm in quadrant 2 overall. Now I come to the ends of my quadrants. I draw my arrows at the ends of the quadrants, and now I'm going to connect it with a smooth curve. Down, down, and connect. Something to note is we're going to expect for this to be a star shape, for them to be diagonal from each other, like this, or that, this, or that, this, or that. And so we're expecting it to be across. Let's see if that's true. Negative 1.5, and I'm down to negative 12. Okay, so here I'm just drawing the arrow, just like we did with cubic functions. We just draw the arrow at negative 1.5, facing down to negative 12, which is off the graph. This one I labeled with numbers, unlike with the polynomials. Then we're at negative 1, negative 9. I see that coordinate. And then I'm for domain, so let me know when you've got it. Tell us what it is.
Okay, it's negative infinity, -2, and then -2 and infinity.
Don't forget the U. And what's really important here is that these are soft. Did you guys notice that? These are soft brackets. They have to be soft brackets. If you didn't notice that, please notice that. So this is very nice, thank you. For the range, we're gonna have a similar pattern. We're gonna use the K value. Lila, what do we have for the range?
I'm not sure, I just finished taking the test.
Just jumped in, okay, so then Sydney, back to you. What do we have for the range? Oh, up. Very nice, loving it. It's already impacting from you, don't need to write it twice. Awesome, now we're looking at the increasing and decreasing intervals. We haven't talked about this yet. Let's take a minute and trace the function using our hands. The hands connect to the brain, you know that. And so to find out the increasing and decreasing interval, we always start on the left. And so if I start on the left, I find my graph and it's here. And then I'm going down. Then here I start, then for the next piece I pick it up, it's actually all the way up at the top, and I'm going down. So for the parent, it decreases. Did you guys see that? Hey, did you trace it with your own hand? My brain connected to my body because I did the action. So now if you start on the left here, you start right here, please trace the function with your finger. I'd like to see you doing that. Start on the left. Was your finger going up or down? Up or down? Up. Good. Up means increasing. So it increased. Did it increase for both pieces or for just one of the pieces? Both? So then we're gonna list the domain for the increasing interval. The domain is negative infinity, 2, -2, union, -2 to infinity. When you traced it with your hand, was it decreasing? What's the answer for not decreasing? NA or empty set? When did it decrease? Our horizontal and vertical asymptote, there are formulas for right here. X equals the X value, Y equals the Y value from the HK. Please write those in if you haven't already. So, Anthony, what did you write in for the horizontal asymptote? Well, up here, the horizontal asymptote is defined as Y equals K. It's where the horizontal boundary line is that we drew. And we have it at what? Okay, so it needs to be an equation of a line, so we're halfway there. Y equals, finish it. Very nice. So see how we have to put the whole thing? Just like for the axis of symmetry, this is an equation of a line, and without the equation chart, equal sign, it doesn't have enough meaning for you to earn points. In the back, yes, thank you. So then for our vertical asymptote, it's a very similar equation, but not the exact same. Yvonne, what do we have for this? Very nice. X equals -2, the X value of the HK. Lauren.
Can you explain again why the
When I traced this, it went up, and then it went up. It did not go down. And so if it increases and decreases, we'll have something there, but because it only increases, This function, when you trace it, goes down and
You
turns
can't
around and
see
comes
it.
up. It has a turning point. These functions only go in one direction. So the way that you can tell increasing and decreasing, use your hands. I expect you to be tracing on the tests and on the quizzes. Those of you not doing it that way, you might be misunderstanding increasing and decreasing. The work for the x and y intercepts. The work to find the x and y intercepts is almost always the same first step. What is our first step for finding the x-intercept, Yassine? Very nice. We're gonna set y to 0. So we know that the 0 is in the position of y. So let's do that now. 0 equals. It's replacing the f of x. And then I'm gonna write down the equation. It says negative 3 x plus 2 minus 6. Now we already know the x-intercept, right? And the y-intercept. We found them in the table. So I want us to use algebra to confirm that we know the steps to get the answers that we found here. That way we have double validation on our notes. So I'm noticing here that x is in the denominator, dividing 3, and then subtracting 6. Hopefully the first step is somewhat clear. What would your first step be to get x by itself, Gavin? Not multiply. Here's x, and if I cover up x, I can see the thing left over that I need to get rid of. What do I need to get rid of? Good, we're gonna add 6 to both sides. That's gonna give me 6 is equal to negative 3 quantity x plus 2 in the denominator. At this step, to get rid of the division by x plus 2, to get x plus 2 out of the denominator, we have to be pretty clever. What are we gonna do? What would be our first next step? We are going to multiply like Gavin said. What do we want to multiply by? Lauren? Very nice. We're going to multiply both sides by x plus 2. That's going to give me 6x plus 2 equals. So what happens on this side? Well, this is very beautiful and super, super important because this is going to be a preview of what's coming up next. Is x plus 2 an exact match with x plus 2? Yes, it is. And so this x plus 2 quantity cancels out with this x plus 2 quantity. That is a humongous conceptual idea that an exact match cancels out with an exact match. A binomial can cancel out a binomial. A binomial cannot cancel out a monomial. A binomial can cancel out a binomial. Binomial, binomial cancels out. Monomial, binomial, no cancel. Has to be the same type of thing. Same number of terms, exact match. So all that's left on this side now is negative 3. Now you could divide by 6 and have a fraction, but I think you probably want to distribute x. Is that right? Keep going and solve for x. We're going to distribute. So after we distribute, Yuna, are you with us? Yes? What would our next step be for this left side? Plus 12. Great. We're going to continue to solve. Ryder, what do we do next?
Subtract 12.
That gives me 6x is equal to negative 15. What's my last step, Chris?
Divide by 6.
Divide by 6. Now, are 15 and 6 relatively prime? No. So that means we need to divide the top and the bottom by the number that we can divide both of these by. What is that number, Jace? Which gives me the number negative 5 over 2. Or, what's another way of expressing the number negative 5 over 2 as a decimal? Naomi? Sort of. Don't forget this. And is that what we found on our table of values and on our graph? Is this negative negative 2.5? Did we have the coordinate negative 2.5 comma 0? Yes, we did. So that is super encouraging. That means that, number one, our algebra confirms our graph, and our graph confirms our algebra. So, what were the steps to solve for x? We isolated the fraction, then we multiplied both sides by the binomial. That was a unique step. Then we just solved for x. Easy enough. We always have the same work to find the y-intercept. What's our first step every time we You said that really fast, and I didn't catch it. Make x equal to 0. So that's going to say f of x equals, and I'm just going to write it down here, negative 3 over 0 plus 2 minus 6. 0 plus 2 is no big wow. That's negative 3 over 2 minus 6. Now here, you're kind of like stumbling. You're like, do I convert to a decimal? Do I get a common denominator? I think that converting it to a decimal is going to be easier. I could be wrong. But I always think of decimals in money, and that really helps me. So negative 3 over 2, what decimal